Alright, let's look at the homework 6.1, problem number 10. Alright, so we want to find the b value so that the y equals b, which is the horizontal line. It's going to divide a region bounded by y equals 9x squared and the y equals 9 into 2 region with equal area. Alright, so let's do that. Alright, so first we need to find the entire area first. So we're gonna do this. Alright, so we want x squared, 9x squared. So this is just going to be a parabola. So we know how to draw the parabola. So it's going to look like this. Alright, it's nice and symmetric. So this is y equals 9x squared. Right? Then you have a line y equals 9. So this is going to be a line which y equals 9. So y equals 9. So we're talking about the region right here. Alright? So let's find a region. We can actually do it either way. We can do it with respect to x, or we can do it with respect to y. For the first one, I'll do it with respect to x. How about that? Alright, so we want to find the actual area. So area there is going to be integral. Looks like from we have to find these values. So here. Alright, and here. Okay. Alright, we can just set these guys equal to each other. So you have a 9x squared equals 9. And divide through by 9, you get x equals 1. So if you take the square root, so x is equal to plus or minus 1. So it looks like we're going from -1 to +1. And then the top curve is going to be 9, which is a straight line, minus 9x squared. Right? And but since you can see that it's symmetric, so we can actually, instead of doing from -1 to 1, we can actually get half of the region, then multiply by 2. Let's do it that way. So it's a probability computation. It's a little simpler. 0 to 1, and then you have a 9 minus 9x squared dx. Right? Since 9 is in common, so we can pull this guy out. So it's a 9 times 2 is 18, and then integral from 0 to 1, and then you have 9's already pulled out, so 1 minus x squared dx. Right? So, and I'm going to clean this up a bit. Alright, so then you have antiderivative, fairly simple. So you have 18. Antiderivative 1 is x. Antiderivative x squared would be x cubed over 3, going from 0 to 1. Alright, which is going to be 18 times, plugging 1. So 1 minus 1/3, so it's a 2/3. Minus plugging 0 is 0, right? So we're gonna get 36 over 3, which is 12, right? So entire region is 12, so we have to make sure that whatever the b is, so I'm gonna cut this at the y equals b, and which means that the area has to be half of that, so area has to be 6 over here and also 6 over there. Right? So let's see, if this is 6, we can see that this region right here, so I'm going to just shade it right here with maybe yellow. Alright, this region is a half of 6. So this region should be 3. So area there should be 3 there. So what we can do is we can set up an integral. I'm going to call this guy area B. So I'm going to call it B. Right? So area B is equal to, right? I'm going to do it in terms of y. Right here, this equation is y equals 9x squared. We can rewrite it by dividing by 9, so it's a y over 9 equals x squared. By taking a square root, so it's a plus or minus square root of x over 3. So actually, square root of y, that's what I meant. So here, y is equal to x. Right? So equation is a square root of y over 3. So we have square root of y over 3. Right? Then you are evaluating the integral from 0 to b with respect to y. Right? So we want this region to be 3. So we're going to set that equal to 3. Right? So, but we need to evaluate this guy. So this is can be written as y to the 1/2 power over 3. So which means that the add 1 to the power. So it's let's add 1 3/2, and then divide by 3/2 is multiplied by 2/3. So it's going to be 2 over 9 because 1/3 is already there. And then you're going from 0 to b. So area there is 2 over 9 b to the 3/2 power. Right? So we just have to find b. Alright, this is equal to 3, so I'm going to multiply both sides by 9 over 2. So it's going to be 27 over 2 is equal to, now over to b to the 3/2 power. Right? So this is going to be equal to taking the, raise it to the 2/3 power. Alright? So we get, let's see, so we're going to get 27 over 2, raise it to the 2/3 power, is going to be b. Right? So let's find this value by GeoGebra. Alright, so we need to find, let's see, GeoGebra, using the GeoGebra, 27 over 2, raise it to the 2/3 power. Right? So what's that value? Alright, it's 5.67. So it's about the 5.67. So let's type it in. So 5.67. Alright, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.